Myself Vijay Lakshmi Sugnali and you are watching my channel WinMaths where I upload videos for second PUC NCRT. If you are preparing, then my YouTube channel is very helpful for your annual exam. So students, I upload videos here. Do watch and subscribe my channel WinMaths. Here today's session we have to solve the exercise 4.6. From this exercise problem, there is a one compulsory 5 marks questions will be asked for examination. Here the question is examine the consistency of the system of equation. We already discussed the theory part in the last session. Here before going to check the consistency, we have to know the solution types. Here I am explaining the solution types. There are three solution types are there. Okay. For example, first one type is when I am taking first one solution type is that is a1 divided by a2 is not equals to b1 divided by b2. Okay. This condition is always we have unique solution. We get unique solution when a1 divided by a2. If we have to consider two system of linear equation, then a1 divided by a2 is not equals to b1 divided by b2. We have unique solution. Then the result is unique solution and result is consistency. We get consistency. Okay. For the second type, okay, for second type a1 divided by a2 equals to b1 divided by b2 c1 divided by c2. For this condition obeys, we have infinitely many solution. Infinitely many solution. Infinitely many solution. Here also we get consistency. Okay. Here also we know the consistency. Okay. Then there is a last one type, that is or third type, that is a1 divided by a2 equals to b1 divided by b2 but not equals to c1 divided by c2. For this condition, solution does not exist. Solution does not exist. It means there is no solution. It means there is no solution. Solution does not exist. Here the solution is inconsistency. Okay, the solution is inconsistency. Now we have three solution types. One is unique solution, another one is infinitely many solution, then solution does not exist. Here have to check these solution types for the exercise problem 1. Here they given equation x plus 2y equals to 2. The equation of the form ax plus by is equals to c. Okay, the system of equation of the form ax plus by is equals to c, and the second equation also of the type ax plus by equals to c. Here for first equation we have to consider a1 b1 c1. For second equation we consider a2x b2y equals to c2. Okay, now we have to check the solution type. We already know the solution type, that is a1 divided by a2 not equals to b1 by b2, then it is unique solution and it is a consistency. a1 divided by a2 equals to b1 divided by b2 c1 divided by c2. Here we get infinitely many solution, that time also we get consistency. Now we have to check here. Okay, first A1 means there is no element constant here. Have to consider 1. Therefore, A1 is equals to 1 divided by 2 and B1 divided by B2, that is 2 by 3. 1 by 2 not equals to 2 by 3. Okay, 1 by 2 is not equals to 2 by 3. Therefore, the system of equation is, it is consistency and unique solution. It is a consistency and has a unique solution. The first one is completed. Okay. Similarly, we have to check for second question. Okay. That is A1 divided by A2. That is 2 divided by 1 is equals to, here B1 divided by B2, that is minus 1 divided by 1. A1 divided by not A1 divided by A2 not equals to B1 by B2. Therefore, it is also consistency. This is also consistency and unique solution. This is also consistency and unique solution. Then now have to check the condition for third equation. That is x plus 3y is equals to 5 divided, and another one equation 2x plus 6y equals to 8. Now have to check x divided 1 divided by 2 equals to 3 divided by 6. What is the 3 divided by 6? This is also 1 by 2, 1 by 2. Here a1 by a2 is 1 by 2. Again b1 by b2 is also 1 by 2. But now check for the c1, 5 by 8. Okay, this is the inconsistency. Okay, here there is a1 divided by a2 is 1 by 2. b1 divided by b2 both are equal but not equals to c1 divided by c2. Okay, it is also, it is inconsistency. Therefore, it is inconsistency and solution not exist. Solution not exist. Okay, next. Now check for the fourth one question. First have to check for these two statements after taking these two after that. Okay, now first check first and second condition, that is a1 by a2, that is 1 by 2 is equals to 1 by 3. Both are not equals. Okay, here a1 is 1 by 1, a2 is 2, 1 by 2, b1 b2, b1 is 1, b2 is 1 by 3. Okay, therefore for equation 1 and 2 are consistency. Then I will check for, here the result is for equation 1 and 2. Now I am checking the consistency for second one, that is 2 by a is equals to 3 by a. 2 by a is not equals to 3 by a, therefore which is also not equals to. From taking 2 and 3. Similarly, I am checking, the equation 1 and 4. Sorry, 1 and 3. That is 1 by a is equals to 1 by a. Now I am checking the last one result, 1 divided by 4. 1 by a equals to 1 by a but not equals to 1 by 4. Therefore, from 1 and 3, both, sorry, 3 equations are here. 3 conditions is also have the consistency. Therefore, the equations are consistency and unique solution. Okay, next have to consider the question number 5. Okay, here just I am taking first and second condition. 3 divided by 2 is equals to, here y by z, that is minus 1 by minus 1, it becomes 3 by 2 is equals to 1 by 1. Okay, a1 by a2 not equals to b1 by b2. Therefore the equation is consistency and have the unique solution. Consistency and unique solution. Now I am checking the sixth one question. Here first I am considering first two equations. Equation 5 divided by 2 is not equals to minus 1 by 3. Not equals to this condition. Therefore the equation is consistency and unique solution. Okay, just you have to know the concept of solution type, and basically 3 conditions have to be remembered. Sometimes this question may ask for 2 marks. Okay, now the next question is solve the system of linear equation using the matrix method. Okay, here the steps I already explained in the last session. Once again I will explain the steps for the solving the system of linear equation by using the matrix method. First step, again first step, have to write of you have to write of the form, write in the form of ax is equals to b. Then second step, find determinant of a. Then a is non-singular, a is non-singular. When solving the system of linear equation using matrix method, these the main steps. First step is have to write the given linear equation of the form ax equals to b. Second step, find determinant of a. If a is non-singular, it means determinant of a is not equals to 0, then you have to proceed. Then third step, find a inverse, that is using the formula a inverse is equals to 1 by determinant of A into adjoint of A. Then fourth steps, for finding the A inverse, have to substitute x is equals to A inverse into B. Here substitute A inverse. After that take multiplication, multiply A inverse into B. Then we have to get the result of x. This is the basic steps for finding the linear equation using the matrix method. Now we have to solve. Now the first question is solve the system of linear equation using the matrix method. Okay, the question number 7 up to 6 we already uh, solved. Now the question number 7 is solve the system of linear equation using matrix method. That is, here they given system of linear equation. Now the first step is the system of equation can be written as, the system of equation can be written of in the form, written in the form, okay, ax equals to b. Okay, the system of equation can be written in the form of ax equals to b. Now a matrix containing the elements, okay, the corresponding elements of x and y, that is 5 2 7 3, and x matrix containing the elements x y, and b matrix containing the elements 4 and 5. Okay, now the second step, have to find the determinant of a. Determinant of a is equals to multiply. Okay, that is 5 to 7 3, 5 into 3 15, 7 into 2 that is 14, 15 minus 14 that is equals to 1. 1 is not equals to 0, therefore determinant of a is non-singular. Non-singular. Then have to check the next step. We want a inverse. Okay, we want a inverse, therefore a inverse formula, a inverse is equals to 1 by determinant of a into adjoint of a. Okay, now have to find the adjoint of a using the A matrix. Adjoint of a is equals to, here we have 2 cross 2 matrix. Now finding the adjoint of a is by interchanging the diagonal elements and multiply, change the sign of the non-diagonal elements. Here 5 3, interchange these 3 5 and multiply the negative sign to the non-diagonal elements, that is -7 and -2. This is the adjoint of the A matrix. Now I have to substitute A inverse is equals to determinant of A, that is 1, so neglect it. A inverse is equals to adjoint of A, that is 3 minus 2 minus 7 and 5. This is the A inverse. Now then x is equals to A inverse of B. Substitute A inverse and B values, we get x. X is equals to, what is the A inverse? We already here, that is 3 minus 2 minus 7 and 5. Multiply B matrix. What are the elements? 4 5. Okay, taking multiplication row by column, x is equals to 3 into 4, 3 4s are 12, minus 2 into 5, that is minus 10, minus 7 into 4, minus 28, 5 into 5 plus 25. Okay, therefore x is equals to, have to subtract 12 minus 10, 2 minus 28 plus 25, that is minus 3. Therefore comparing the x matrix with, that is x is equals to 2 and y is equals to 3, which is the required solution of the non-linear equation of x is equals to 2 and y is equals to 3. Okay, here this is also important. You have to remember the steps for solving the solution. Okay, now that is, I will explain once. Here first step is, have to write the system of linear equation of the form ax equals to b. Okay, here x and y having the corresponding values, that is written in matrix form. Here only they given two linear equation, therefore two rows. Okay, here x is equals to finding the variables, x and y are variables, I am taking as a column matrix, and 4 5 is also taking column matrix. Okay, next step is for finding the determinant, that is 1, which is not equals to 0, therefore determinant of a is non-singular. Then we want a inverse. How to find the a inverse? We know the formula, 1 divided by determinant of a into adjoint of a. Okay, when 2 cross 2 matrix are taken, the simplest form for finding the adjoint is interchanging the diagonal elements and change the sign of the non-diagonal elements. Okay, now we get the A inverse. After substitute A inverse in the equation, x is equals to A inverse B, then taking multiplication row by column, we get x values. Okay, same method is follow for 3 cross 3 matrix, because in the examination 3 cross 3 matrix will be asked for examination for 5 marks. This is the mainly there are 3 questions are there. Out of 3 questions, one question will be definitely as for annual exam as well as in midterm exam. Okay, now we have to solve the eighth question. Okay, here also the steps one is the system of equation. The system of equation can be written. The system of equation can be written in the form Ax is equals to B, where A matrix containing the elements, the corresponding 2 here minus 1, 2 minus 1, 3, 4, and X matrix containing the values variables x, y, and B matrix containing the values minus 2, 3. Okay, here we have A, X and B matrix. Now the second step is for find the determinant of A. What is the determinant of A? 2 minus 1, 3, 4. Have to find now. 2 into 4, that is 8. 3 into 1 minus 3, here is a 1 minus, that is plus 3. 5 plus, sorry, 8 plus 3, it becomes 11. Determinant of A is equals to 11. 11 is not equals to 0. Therefore, determinant of A is non-singular. Here, determinant of A is non-singular. Now, the next step is have to find the A inverse. We want A inverse. Again, A inverse is equals to 1 by determinant of A is into adjoint of A. First, we have to find the adjoint of A after substitute in the equation. Here, adjoint of A is changing the non-diagonal elements. Okay, that is 4, 2, and just change the sign of the non-diagonal elements, that is minus 3 plus 1. Okay, have to multiply minus, it becomes minus 3. Here minus into minus, it is plus. Now we get the adjoint of A. Again substitute A adjoint of A in this equation. A inverse is equals to 1 by determinant of A will be, what is that, 11 into adjoint matrix, that is 4, 1 minus 3, 2. Okay, now have to find the X. Then X is equals to A inverse into B. Okay, here X matrix, what is the A inverse? 1 divided by 11 into 4, 1 minus 3, 2 into B matrix. What are the elements? Minus 2, 3. Okay, X is equals to, I am taking 1 by 11 as a constant. Then multiplication row by column. 4 into minus 2, it becomes minus 8. 1 into 3 plus 3. Minus into minus, plus 3 to the 6. 2 into 3, that is also 6. Okay, here X is equals to 1 by 11 minus 8 plus 3, it becomes minus 5. 6 plus 6, it is 12. Okay, we get X is equals to 1 by 11 into minus 5 by 12. Okay, therefore taking multiply, X is equals to 1 by 11 on matrix, that is minus 5 by 11 and 12 by 11. Therefore, X is equals to minus 5 by 11 and Y is equals to 12 by 11. This is the required solution of the given problem. Okay, now solve the next one. Here the question number 11. Have to find the non-linear equation using the matrix method. Here first step, have to write the system of equation. Okay, the system of equation of the form, the system of equation of the form Ax is equals to B, where A be a matrix containing the elements. Here 2 1 1, the corresponding elements of X is 2 1 1. Here 1 minus 2 minus 1. Here X is not present, therefore I am taking as a 0, 3 and minus 5. Okay, then B is equals to 1 3 by 2 9, and X matrix containing the variable X Y Z. Okay, second step, have to find the determinant of A. Okay, here determinant of A is equals to 2 1 1 1 minus 2 minus 1 0 3 minus 5. Okay, I am taking by column 2 into, here minus 1 into minus 2 into 5, that is minus 10, minus into minus plus. Okay, plus 10. 3 into minus 1, 3 into minus 1, it becomes minus 3, minus 3, here 1 minus, it becomes plus 3, minus 1 into, again neglecting this row, column 1 into 5 minus 5, 3 into 1 3, here there is a 1 minus, minus 3, therefore 0 into anything, it becomes 0. The answer is 2 into 10 plus 3, 13, minus 1 into minus 5 minus 3, minus 8. 13 to the 26, minus into minus plus 8 into 1, 8. 26 plus 8, it becomes 34, which is not equals to 0. Therefore, determinant of A is non-singular. Determinant of A is non-singular. Now have to find the next A inverse. Okay, now find A inverse using 1 divided by determinant of A into adjoint of A. Okay, we already know the determinant value. Now have to find the adjoint of A. Okay, now adjoint of A means the transfers of the cofactor matrix. Before going to cofactor, we have to find the minor. So I am directly find the minor, cofactor as well as adjoint. Okay, here first element I am considering, that is A1. The first element is A1. Directly I am taking A1, A11, here A12, A13. Okay, the first element A1, A12, A13. That is neglecting this row, column. What is that? Minus 2, minus 1, 3, minus 5. Again, for the second row, neglect this column and row. What are the elements left? 1, minus 1, 0, minus 5. Okay, again, I am considering 1, neglecting this, we get the determinant 1 minus 2, 0, 3. Okay, similarly, I am finding all the elements A21, A22, A23. Again, A31, A33, sorry, A32 and A33. First have to write the each of the cofactors first. Okay, now A21 for the second row. Okay, first element of this row, neglect column and deleting this, we get the determinant 1 1 3 minus 5. Again for middle element 2 1 0 minus 5, 2 1 0 minus 5. Okay, next for A23, for A 2 3, 2 1 0 3. Next 1 1 minus 2 minus 1. Okay. Next 2 1 1 minus. Here the last one is 2 1 1 minus 2. Now have to find all the determinants. Okay. Here minus 2 into minus 5, that is minus 10. 3 into minus 1, minus 3. Then the answer becomes here minus 2 into minus 5, that is 10. 3 into 1, minus 3, here 1 3 plus 3, it becomes 13. Okay. 1 into 5 minus 5, 0 into 0, it becomes a minus 5. Then 1 into 3, 3 plus 0, it becomes 3. Next 1 into minus 5, minus 5, 3 into 1, 3, there is a 1 minus, that is minus 3, minus 8. 2 into minus 5, minus 10. 0 into 1, minus 0, it becomes minus 10 only. Then the next one is, okay, the next one is 2 into 3, 6. 0 into minus 0 into 1, 0, it becomes 6. 1 into minus 1, minus 1. Minus 2 into 1, minus 2, there is a 1 minus, it becomes plus 2. Okay, again the last two elements are there, that is 2 into minus 1 minus 2, 1 into 1 minus 1, it becomes minus 3. 2 into minus 2 minus 4, 1 into minus 1, it becomes minus 5. Okay, these are the corresponding minus. For this minus, I am directly taking signs. Okay, I am directly taking signs here, plus minus plus minus plus minus plus minus plus. Okay, here I am changing sign, corresponding signs. Then we get cofactors now. Plus into 13, 13 minus into minus, plus again plus into 3, it becomes plus 3 minus into minus, plus 8, plus into minus, minus 10, minus 6. Here plus into 1, it becomes 1, minus into minus, plus, plus into minus, minus. Okay, I am grouping three elements, that is A11, A12, A13. For second one, I am arranging this group in the column matrix. Okay, I am arranging directly, that is adjoint of A is, I am arranging in a column, that is 13, 5, 3. Second column 8 minus 10 minus 6. Third column 1, 3 minus 5. Here I am getting the adjoint of A. Okay. Therefore, now A inverse is equals to 1 by determinant of A, that is 34 into adjoint of A. 13, 8, 1, 5, 10, 3, 3 minus 6 minus 5. Okay. Now the last step is find x. X is equals to A inverse into B. Again substitute A inverse and B value. What is the A inverse? 1 divided by 34 into A inverse 13, 8, 1, 5 minus 10, 3 minus 6 minus 5 into B matrix containing the elements. What are those? 1, 3 by 2 and 9. Okay, taking multiplication row by column. Here I am taking the multiplication row by column. Then it becomes x is equals to, okay, I am taking here, that is x is equals to 13 into 1, it becomes 13. 8 into 3 by 2, okay, that is 8 into 3 by 2. 2 ones are 2 fours are 4 threes are 12. Here plus 12. 1 into 9, it is 9. Next 5 into 1, it becomes 5. Minus 10 into 3 by 2, minus 10 into 3 by 2. 2 ones are 2 fives are 5 threes are 15, that is minus 15. 3 into 9, it becomes 27. Next 3 into 1 3 minus 6 into 3 by 2, minus 6 into 3 by 2. 2 ones are 2 threes are minus 3 into 3 minus 9, minus 5 into 9 minus 45. Okay, now add these values. We get here there is a 31 by 34. 13 plus 12, 25. 25 plus 9, 25 plus 9, it becomes 34. Here 15 minus 5 minus 10, minus 10 plus 27, that is minus 17. Here minus 9 plus 3 minus 6, minus 6 minus 45, it becomes minus 51. Therefore, divide each element by 34. It is 34 divided by 34 minus 17 by 34 and minus 51 divided by 34. Then the values becomes 34 ones are 34, 1. Here 17 ones are 17 twos are, that is minus 1 by 2. Here 17 threes are 51, 17 twos are, that is minus 3 by. Therefore, x is equals to 1, y is equals to minus 1 by 2 and z is equals to minus 3 by 2. This is the one of the important problem for 5 marks. So, practice now. Okay, up to this much it is complete. Have to maintain these steps. It is easier to solve the problems. Okay, next question. Question number 12. Have to solve the same method. Okay, then the system of equation of the form ax is equals to b. Here a matrix containing the elements 1 minus 1 1, 1 minus 1 1, 2 1 minus 3 1 1 1, and X matrix containing the variables x, y, z, and B matrix containing the variables 4 0 2. Okay, now find the determinant of A. Here determinant of A is equals to 1 minus 1 1, 2 1 minus 3 1 1 1. Now have to find the determinant by using row 1 into, here 1 into 1 1, 1 into minus 3 there is a 1 minus, it becomes plus 3, minus 2, neglect these row, column minus 1 into 1 minus 1, 1 into minus 1. Okay, again plus 1 into, neglecting these row, column minus 1 into minus 3, it becomes plus 3, 1 into 1 minus 1. Okay, 1 into 1 plus 3, it becomes 4, minus 2 into minus 2 plus 1 into 3 minus 1, it is 2. Okay, 1 into 4, minus 2 into minus 2 plus 4, 1 into 2, it becomes 2. 4 plus 4, 2, that is 10. Determinant of A is 10. Then now determinant of A not equals to 0, therefore A is non-singular. Okay, A is non-singular. Then now find A inverse using the formula 1 by determinant of A into adjoint of A. Okay, we want adjoint of A. I am directly finding the adjoint of A by using the elements of matrix. Okay, first I have to write all the elements. First one is A11, that is neglecting first and column. 1 minus 3, 1, 1. A12, that is 2 minus 3, 1, 1. A13, 2, 1, 1, 1. A21, that is minus 1, 1, 1, 1. A22, A22, 1, 1, 1, 1. Then A23, directly 1 minus 1, 1, 1. A31, minus 1, 1, 1 minus 3. Again A32. The elements A32. What are those? 1, 1, 2 minus 3. Then A33. That is 1 minus 1, 2, 1. Now have to find the values of each elements. Okay, that is here find the values. 1 into 1, 1. 1 into minus 3. Minus 3 here 1 minus, it becomes plus, that is 4. 2 into 1, 2. 3 into 1 plus 3, 5. 2 into 1, 2. Minus 1, it becomes 1. Minus 1 into 1, minus 1. Here minus 1, it becomes minus 2. 1 into 1, 1 into 1. 1 minus 1 becomes 0. Again 1 into 1, 1 into minus 1, it becomes plus 1. 1 into 1, 2. Next minus 1 into 3 plus 3. 1 into 1 minus 1, it becomes plus 2. 1 into minus 3 minus 3. 2 into 1 minus 2, it becomes minus 5. The last one 1 into 1, that is 1. Here plus 2, it becomes 3. Okay, now have to multiply the sign now. Okay, have to multiply the sign, taking sign here, starting with plus, plus, minus, plus, minus, plus, minus, plus, minus, plus. Starts with plus as well as end with plus. Okay, alternative symbols have to multiply. Then we get cofactor. Okay, what is the cofactor? Here it is plus into 4. 4 minus 5, 1 minus into minus plus 2. Here 0 minus 2 and plus 2 minus into minus plus 5 as now plus 3. Okay, now have to write the adjoint by grouping the elements. Okay, have to find the grouping the elements. Taking by column. Okay. Now directly I am writing adjoint. Adjoint of A is equals to, write these three elements by grouping as a column, that is 4 minus 5 1, second column 2 0 minus 2 and 2 5 3. Okay, have to write by column wise only, that is adjoint of A. Now A inverse becomes, A inverse is equals to 1 divided by 10 into adjoint of A, that is 4 2 2 minus 5 0 5 1 minus 2 3. Okay, again have to find the x is equals to A inverse into B. Now substitute the values. A inverse, okay, that is 1 by 10 into determinant of A inverse 4 2 2 minus 5 0 5 1 minus 2 3, and B matrix 4 0. Okay, now take the multiplication by row by column. Okay, row by columns. So x is equals to 1 by 10 into 4 into 4 16, 2 into 0 0, 2 to the 4, minus 5 into 4 minus 20, minus 0 into 0 0, 5 to the 10, 1 into 4 it becomes 4, minus 2 into 0 0, 3 into 2 6. Okay, we get that is equals to x is equals to 1 by 10 into 16 plus 4 20, minus 20 plus 10 minus 10, 4 plus 6 10. Multiply each element by 10, we get x is equals to, x is equals to 2 minus 1 1. Therefore x is equals to 2, y is equals to minus 1 and z is equals to 1. This is the solution of the question number 12. Okay, when you practice more you get good results. Okay, then the next question number 13, that is 2x plus 3y plus 3z is equals to 5, x minus 2y plus z is equals to minus 4, 3x minus y minus 2z equals to 3. The first step, the system of equation, the system of linear equation written in the form Ax is equals to B. Here A matrix containing the elements 2 3 3, 1 minus 2 1, 3 minus 1 minus 2, and X be a matrix containing the elements x y z, and y b be a matrix containing the values minus 5 minus 4 3. This question will be asked 2 times in the annual exam. Okay, this is very important question. Now second step, find the determinant of A. Determinant of A is equals to 2 3 3, 1 minus 2 1, 3 minus 1 minus 2. Now I have to find the determinant value by using the column 2 into, here minus 2 into minus 2 plus 4, minus 1 into 1 minus 1, here 1 minus, that is plus, minus 1 into, neglect these, 3 into minus 2 minus 6, minus 1 into 3 minus 3, it becomes plus 3, 3 into 1 3 plus, here minus 2 into 3 minus 6, here 1 minus, it becomes plus. Now the value 2 into 5 minus 6 plus 3, it becomes minus 3 plus 3 into 9. Okay, 2 into 5, 10, minus into minus plus 3, minus plus 9 3s are 27. It becomes 37 plus 3, 30 plus 10, 40, which is not equals to 0. Therefore, determinant of A is non-singular. Determinant of A is non-singular. Now, I have to find the A inverse. Find A inverse, that is 1 divided by determinant of A into adjoint of A. I am finding the directly adjoint of A by considering the A11 cofactors, that is A11, A12, A13. Here for A11 matrix, the values of 2, so deleting the first row column, here minus 2, 1, minus 1, minus 2. Again for the second element, 1, 1, 3, minus 2. Next, 1, minus 2, 3, minus 1. Okay, now A21, A22, A23. Here I am considering A31, A32, A33. Okay, for A21, the elements 3, 3, minus 1, minus 2, 3, 3, minus 1, minus 2. For this one, 2, 3, 3 minus 2, 2, 3, 3 minus 2. Next, for the element 2, 3, 3 minus 1. Next, 3, 3 minus 2, 1, 2, 3, 1, 1. Last element 2, 3, 1 minus 2. Now have to find the values here. Minus 2 into minus 2, it becomes plus 4. Minus 1 into 1, minus 1, here 1, that is 5. Minus 1 into 2, minus 2, minus 3, it becomes minus 5. 1 into minus 1, minus 1, plus 6, it becomes 5. 3 into 2, minus 6, plus 3, it is minus 3. 2 2s are minus 4, minus 9, it is minus 13. Next, 2 into 1. 2 into 1 minus 2 minus 9 minus 11. 3 ones are 3 plus 6, it is 9. Then last one, 2 minus 3, it is minus 1, and minus 4 minus 3 minus 7. Okay, now I have to change the signs. Okay, I have to change the sign, that is plus minus plus minus plus minus plus minus plus. We get cofactors, that is 5 minus into minus plus plus 5 plus 3, here minus 13 plus 11 plus 9 plus 1, and finally minus 7. Okay, now I am directly writing the adjoint by grouping. Okay, by grouping the elements. This is first one, second one, and third one. Okay, now adjoint of A is, or writing all the elements by column. 5, 5, 5. Okay, then 3 minus 13, 11, 9, 1 minus 7. Okay, here 25 plus 2, 52 plus 3, 60, 60 plus 25, which, okay, 25 plus 52, it becomes 50 plus 20, 70, 77, and it becomes 80. Now 25, 25, okay, here minus 44 minus 21, that is 40 plus 20, 60, 65 plus 20, 65 minus 20 minus 40. Okay, now multiply each value by 40, then x is equals to 40 ones are 40, 42s are 40 minus 1. Therefore the values therefore the values are x is equals to 1, y is equals to 2, and z is equals to minus 1. Last question of this exercise is, as well as this is the one of the important question, most of the time this question will be asked in the exam. The system of equation can be written. The system of equation can be written in the form ax is equals to b, where a be a matrix containing the elements 1 minus 1 2. Okay, 3 4 minus 5 2 minus 1 3, and x be a matrix, the variables x y z, and b be a matrix containing the values 7 minus 5 12. Okay, here the next we have to find the determinant of a, that is 1 minus 1 2 3 4 minus 5 2 minus 1 3. Okay, I am finding now 1 into, that is 4 3s are 12, 1 into 5 5, here 1 minus 5, again minus 3 into minus 1 into 3 minus 3, here plus 2 into minus 1 into minus 5 plus 5, 4 2s are 8. Okay, 12 minus 5, 1 into 12 minus 5, that is 7, minus 3 into minus 3 plus 2 minus 1 plus 2 into 5 minus 8 minus 3. Therefore 7 minus 3 into 1 plus 3, 2 3s are minus 6. Okay, 7 plus 3 10, 10 minus 6 4, which is not equals to 0. Therefore determinant of a is non-singular. Okay, the next step is we have to find a inverse using the formula 1 by determinant of a into adjoint of a. Now have to find the adjoint of a by taking the cofactors, that is a11, a12, a13. I am considering the first row, that is the determinant values 4 minus 5 minus 1 3. Then second one 3 minus 5 2 3. Then third one 3 4 2 minus 1. Okay, neglecting the element of which is present, that is a21, a22, here a23. Okay, the elements are a21 minus 1 2 minus 1 2 minus 1 3 1 2 2 3 1 2 2 3, here 1 minus 1 2 minus 1. Again for the third row 3 1 a32 a33. Okay, now a31 that is minus 1, 2, 4, minus 5. Next 1, 2, 3, minus 5, 1, 2, 3, minus 5. Again for the last element 1, minus 1, 3, 4. Okay, now have to find the each values. Okay, 4 3s are 12, minus 1 into 5, minus 5. Here plus 5, there is a 1 minus 5, it becomes plus 7. Now 3 3s are 9, 2 into 5, it becomes 10, that is 19. 3 into minus 1, minus 3, minus 8, minus 11. Okay, I am not explaining each term because it's a last question. I have to practice more. Minus 1 into 3, minus 3. Here for the 2 1 element. Minus 1 2, minus 1 3. Okay, here minus 1. Minus 1 into 3, minus 3. 2 into 1, plus 2. It becomes minus 1. 1 3s are 3, 2 2s are 4. It becomes minus 1. Now 1 into minus 1, 2 into minus 1, it becomes 2. That is plus 1. Minus 1 into minus 5, 5 minus 8, it becomes minus 3. 1 into minus 5, minus 6, minus 11. Again 1 into 4, 4 plus 3. It becomes 7. The next step is have to multiply the sign. Okay. First step have to write each element by neglecting its row and column. Then second step find the determinant. After that have to multiply the sign. First element plus minus plus minus plus minus plus minus. Last one is plus. Now we get the values, that is cofactor. 7 into 1 7. Here minus 19 plus into minus minus 11, minus into minus plus 1, plus into minus minus, plus into minus minus, minus into plus, it becomes minus 3. Again minus into minus plus 11. Then 7 into 1, it becomes 7. Okay, I am directly write the adjoint by combining the rows. Okay, that is adjoint of A is equals to writing each elements by column, that is 7 19 and minus 11. 1 minus 1 minus 1 minus 3 11 and 7. Okay, this is the adjoint of A. Now we want A inverse, that is 1 by determinant of A into adjoint of A. It is 1 by determinant value is 4 into adjoint, that is 7 1 minus 3 minus 19 minus 1 11 minus 11 minus 1 7. Okay, now x is equals to A inverse into B. Substitute here, x is equals to 1 by 4 into A inverse 7 1 minus 3 minus 19 minus 1 11 minus 11 minus 1 7 into B matrix. The elements are 7 minus 5 12. Okay, take multiplication row by column, so have to multiply 1 by 4 into here 7 sevens are 49. 1 into minus 5 minus 3 into 12 12 3s are 36. Okay, next 19 into 7. What do you mean by the 19 into 7? That is 19 into 7 133. 1 minus 133 minus 1 into minus 5, it becomes plus 5. 11 into 12, 12 tens are 120, that is 132, 132. Next minus 11 into 77, okay, minus 1 into 5 plus 5, 12 sevens are 12 fives are 60, 12 six are 84. Okay, now x is equals to 1 by 4. Then here minus minus have to add first. 36 plus 5 or 41. 49 minus 41, it becomes plus 8. 1 minus 133 plus 132, it becomes 1. Okay, here minus 1, 5 minus 1, 4. Next 77 minus 5, 72. 84 minus 72, it becomes 12. Okay, that is, now multiply each by 4, then x is equals to 2 1 3. Therefore x is equals to 1, x is equals to 2, y is equals to 1, and z becomes 3. This is the system of linear equation. Up to this much exercise problems are completed, and these are the, here in this video whatever the problems I am doing, these are so many times asking in annual exam, preparatory exam, as well as in midterm exam. So have to practice only. There are 5 questions are there. If you really practice more, then you will succeed. Okay, easily get 5 marks. Okay, thank you. Thank you for watching my video. If you really like my channel, please like, subscribe and share to your friends. If you have any doubt or when I am done wrong, please comment me. Thank you.